Hi guys, today we'll discuss about Knuth-Morris algorithm. Knuth-Morris algorithm is used to find a pattern inside a string. It helps us finding the starting index where the pattern is matching. So in this case, if you take ISSIPI as a pattern, with the help of Knuth-Morris algorithm, we can find the index from where this pattern is matching. So Knuth-Morris helps us finding this pattern in big of n plus m time complexity. So one of the most efficient algorithms to find a pattern inside a string. In Knuth-Morris algorithm, the main logic behind this solution is how we find the largest prefix and suffix table. So in general, we call it as LPS table. So LPS. So it stands for largest prefix and suffix table. So here we are having a pattern of length 6. So LPS table is going to have length 6. 1, 2, 3, 4, 5, 6. So LPS table is going to be like this. So here we have a string of length 6. So the first one is going to be I. So we'll take an I. So this is of length 1, right? So we can and the prefix and suffix will be of length 1 only. So we'll make it as a 0, okay? And take S. And if you take IS, from this we can generate one prefix and one suffix, that is I and S. And here none of the prefix is matching with the none of the suffix, so it is going to be 0. Okay, and the next one is S. So we take IS and S. So ISS is of length 3, so we can actually generate prefixes and suffixes up to length 2. That means we can generate IS, or we can generate IS or SS, right? Here also none of the prefixes are matching with none of the suffixes. So again it's going to be 0. The next one is ISSI. Here we can generate prefixes and suffixes up to length 3. So starting with length 1, this I and this I. So this is matching. Generate length 2, ISSI, not matching. ISS, SSI, not matching. So the only one matching is of length 1. So we'll give a length 1 here. And the next one is P. Here, we don't have to do all this process because in general, if you just apply some logic here, if there is a unique letter P that has not been repeated in the previous letters, obviously you'll get unique prefixes and unique suffixes. So we can directly put a 0 here. And the next one is I. I is there only once here, right? So I think we probably get 1 here. You can try and generate here ISS, IPI. So of length 1 we can generate I and I. This is matching. But again P is there, so we'll get the unique prefixes and suffixes. So we don't have to do all that. Straight away we can put 1 because 1 is matching. Right? So this is the LPS table. And let me write here again the pattern. MISSI SSIPI, and the pattern is ISSIPI, and the table is 000101. LPS table is going to be like this: 000101. Now we'll take 2 pointers. Let us consider that as a left, or I we can consider I is this and J is this. So J is going to be iterating from here to here, and I is going to be iterating this string. So we'll try iterating the I and we'll compare the element of I with j in every iteration. So in the first iteration, we'll compare I with j. That means we'll compare m with I. It is not matching. So I is going to be incremented, and we'll try comparing I with I. So both are matching. So I is going to be incremented and j is going to be incremented, right? So now S is matching with S, right? So S is going to be, I is going to be incremented and j is going to be incremented. Both are matching. Again, it is going to be incremented. J is also going to be incremented. Both are matching. Again, I is going to be incremented. J is going to be incremented. Now here is the case where element of I is not matching with element of J. So if we don't have the LPS table, what we generally do is we go back to the we go back to the starting of the pattern and we'll try matching from here onwards, ISS, IPL. But since we have the LPS table, we have analyzed the string and we know where this has to start again. Because if you take the previous letter, here it is I is there. I is matched with I. That means again I where it is there in the first location. I mean zeroth location it is there. So from first location we can start comparing. So we can keep the I like this. We can keep the I like this and we can compare this. Let me change the bridge. We can compare this as with the first location. So first location is this. So we can start the pattern matching from here. So through with the help of the LPS table, we know where our pattern should start once there is a mismatch. So if it is 0, that means we have to start from the beginning of the pattern. If there is a position here, that means we can start from that index onwards because LPS table has studied where this pattern is going to be repeated. So this I is going to be repeated here and the I is going to be there here. That means we can start the matching pattern matching from here, right? So that is a basic concept. And if we start here, again, S is going to be as same. So S is going, I is going to be incremented and J is going to be incremented. Both will be matched. Again, same. And if the process continues, you will get the pattern. And in the end, we can return I minus J. This is going to give the index from where this pattern is starting. So that is about the LPS table. And hope you understood. This is also one of the toughest problems that people ask in interviews, especially if you are trying for some big companies like Facebook and Google. You have to be prepared in these concepts, and it is also there in lead code. You can go and attempt. You'll get to learn more. You get to work out how this algorithm can be put into code. So you'll get some nice clarity about how this works in detail. Thank you. We'll see you in the next lecture.